All right, example 2 here is asking us, we're going to use that same diagram that we were using to kind of talk about it. So an isosceles triangle ABC, so that's the triangle over here that we're talking about. And again, so keywords here. That keyword is isosceles, so you want to highlight that, circle it, 2 equal sides, 2 equal angles. Write that stuff down. That's the stuff that's going to get you partial credit. So angle BCA. So remember, when you're using 3 letters to talk about an angle, the letter in the middle is really the angle that we're talking about. So angle BCA, I'm going to highlight in yellow. BCA is really this angle right here, because you follow BCA and you get that angle. So that's my vertex angle, meaning that the other 2 base angles are the ones that are equal. CD is an altitude, they're telling me that. If DB is equal to, okay, so we've got to write some stuff down on our graph, picture. So they give us DB as 3 times 2x minus 1. And then they give us the entire AB. So I'm just going to take this little piece that we wrote down and just move it out of the way. And then I'm going to label that entire AB as that hot mess. Oh, man, decimals and everything. Okay, so find and explain dA. So again, we've got an important piece that we need to explain how we got our equation and why our equation works. So the next keyword, other than the fact that we have an isosceles triangle, which means 2 equal sides and 2 equal angles, I can't do anything with that because they don't give me what those 2 equal sides are. They don't give me expressions for CA or CB. They also don't give me any expressions for the 2 base angles that would be congruent. This angle A here would be congruent to angle B, but we don't know anything about those, so the fact that we have 2 congruent sides and 2 congruent angles doesn't do anything here. So then we continue onward. The next super important keyword that we're seeing here is the fact that we have an altitude. And remember, in an isosceles triangle, the altitude from the vertex bisects the base and the vertex angle, which means that this little green angle is equivalent to that little yellow angle up there. But again, that's not what that's not the information we have. So we know that this altitude bisects the base, or cuts the base into 2 equal parts, which is where we got the AD is equal to or congruent to BD. But I need to write that down because I need to explain how I came up with that. So I'm just going to restate that fact from above. In an isosceles triangle, the altitude from the vertex angle bisects the base, making, and then this is where we come into this, AD congruent to DB. Which means, so that still doesn't quite help me all the way yet because I don't have enough to make an equation yet. They give me the whole thing and they give me this little piece. We now know that these little pieces are equal to each other. So I can label AD with that same expression that I'm labeling DB. This is similar to that stuff we did in Unit 2, where you kind of add the 2 pieces together to get to the whole. That's what we're going to do here. We're going to add those 2 smaller pieces that are equal to get to the whole orange piece. AD plus BD equals AB. Oh, okay, let's write some stuff down. So, go away. So we said AD plus DB is equal to AB. So 3 times 2x 2x minus 1 plus 3 times 2x minus 1 is equal to negative 4 times 3x minus 11 plus 103.6. And this is where we do some wonderful math. 3 times 2 is 6x minus 3 plus another 6x minus 3, negative 12x plus 44 plus 103.6. 103.6 plus 44 gives me 147.6. You like that math there in my head? Carry down my negative 12x plus 6x plus 6x is a 12x. Negative 3 minus 3 more is negative 6. And we're getting there. Go ahead, add that 12x to both sides so you can get all the x's on one side. 24x minus 6 is equal to 147.6 plus 6 to both sides, skipping over the fact that we do have a third example on the back. I don't want to do math in my head anymore. So 147.6 plus 6, and let's just backtrack for a second, make sure that I actually added that right the first time, and I did. So 153, this is looking sketchy. I'm a little, oh my goodness. I'm a little nervous. Last step is to divide both of those sides by 24. And let's see if that works out to be something fabulously nice or something terribly ugly. Divide by 24 is relatively nice. X is equal to 6.4. Okay, so now, again, we made our equation, found X, we explained how we got our equation, but we still need to make sure that we're answering what the question was asking us. It was asking us to find dA. So that would be this piece right here. So I'm going to use that 3 times 2x minus 1 expression to find dA. I'm going to do that in orange. So dA is equal to 3 times 2x minus 1. And in for x, we're putting that 6.4. Order of operations here, since there's no variables inside my parentheses, 6.4 times 2 is 12.8 minus 1 is 11.8. So 3 times 11.8 gives us 35.4 as the measurement for dA. What did I just say? 35.4. Boom.